Hello students, welcome to BitMath exam preparation series. Partial differentiation is the topic. In the previous class, we learned Euler's theorem and how to verify Euler's theorem. In this class, we are going to learn applications of Euler's theorem. So how to apply Euler's theorem when application of Euler's theorem is valid. These things we are going to discuss in this class. So let us start with a problem. Let us take if u equal to or log u, take log u equal to x cube plus y cube divided by 3x plus 4y. Show that x dou u by dou x plus y dou u by dou y equal to 2u log u. Here we are given log u equal to x cube plus y cube by 3x plus 4y. If you see this function x cube plus y cube by 3x plus 4y is a homogeneous function, but not u. What is u from this? U equal to e power, because let us take it as a natural log u to the base e. So u must be from this x cube plus y cube by 3x plus 4y. So if you take u of kx comma ky, replace x and y by kx ky, e power k square into the same thing you will get, because in the numerator you will get k cube, in the denominator k, so k square into something, and you cannot get this k square here, right? So u is not homogeneous, but log u, which is x cube plus y cube by 3x plus 4y, this function is homogeneous. So you name it as a new function, say, and we can apply Euler's theorem for z. So let us start with z. Zxy is x cube plus y cube by 3x plus 4y. So z of kx comma ky is k square into the same thing you will get x cube plus y cube by 3x plus 4y. This we have seen how to get in the previous lecture. K square into z of xy. So therefore z is homogeneous. Of degree n equal to 2, because we have k square here, n equal to 2. Now because z is homogeneous, we can apply Euler's theorem for z. So here u is not homogeneous, so you cannot apply Euler's theorem for u. Therefore Euler's theorem is applicable for z. So therefore x dou z by dou x plus y dou z by dou y must be nz. This is 2z because n is 2. So just by applying Euler's theorem in one line, we got this answer equal to 2z. For the same thing, we manually did it in the previous lecture. You know how long it takes to prove this, right? That is the greatness of Euler's theorem. Now, the job is over with z. But what you are asked to prove x dou u by dou x plus y dou u by dou y equal to dou u log u. So here you have dou u by dou x and dou u by dou y. But we got everything in terms of z. Here dou z by dou x. So, but what is z in terms of u? It is log u, right? So therefore, we substitute z equal to log u back into this equation. What you will get? X into dou by dou x of log u plus y into dou by dou y of log u equal to 2 log u. So this implies x into derivative of log u is 1 by u into dou u by dou x plus derivative of log u with respect to y is again 1 by u dou u by dou y equal to 2 log u. Therefore, x dou u by dou x plus y dou u by dou y must be 2u log u. Okay, so this is how we can apply Euler's theorem and solve some problems. Now, let us take one more problem. If u equal to sin inverse x plus 2y plus 3z by x power 8 plus y power 8 plus z power 8. See, here you have three variables, three independent variables x, y, z. Show that, or sometimes you may be asked like find the value of x dou u by dou x plus y dou u by dou y plus z dou u by dou z. So even though you are asked like this, we have to use Euler's theorem to evaluate this. If you do it manually, like finding dou u by dou x, dou u by dou y, dou u by dou z, and multiply them by x, y, z respectively, add and simplify, it takes a lot of time. So we use Euler's theorem here. So what is given? You can easily notify that sin inverse of x plus y plus 3z by, that means if you replace x by z by kx, ky, kz here inside, you will get k power minus 7 into something in this inside sin inverse. So k power minus 7 into the same thing you will get. But you have sin inverse before that. So you cannot take this k inverse k power 7 minus 7 out of this. So u is not a homogeneous function. U is not a homogeneous function. So you cannot apply Euler's theorem for u directly, right? So let Let us take the given function as sin u equal to x plus 2y plus 3z divided by x power 8 plus y power 8 plus z power 8. So sin inverse of this thing is not homogeneous, but the inside thing is homogeneous. So you take it as w of xyz. You name it as w of xyz. So you take this part, clearly w of kx comma ky comma kz is k power minus 7 into the same thing you will get. So it is again k w of xyz. So this implies w is homogeneous of degree n equal to minus 7. So you can apply Euler's theorem for w, right? Therefore, Euler's theorem is applicable for w. This implies x dou w by dou x plus y dou w by dou z dou y plus z dou w by dou z equal to nw, which is minus 7w. Now replace w equal to, now you take the second part, this one, this and the first one, sin u equal to w. W equal to sin u. So replace w by sin u, x dou by dou x of sin u plus y dou by dou y of sin u plus z dou by dou z of sin u equal to minus 7 sin u. X into dou by dou x of sin u is cos u into dou u by dou x. Y into derivative of sin u is cos u into dou u by dou y. Derivative of u with respect to y. Z into cos u dou u by dou z equal to minus 7u, 7 sin u. So now you take cos u to the right hand side, x dou u by dou x plus y dou u by dou y plus z dou u by dou z equal to minus 7 sin u by cos u, which is minus 7 tan u is the answer. Now let us take a different problem. Of course, is also same type. But this is important. If u equal to tan inverse x cube plus y cube by x plus y, prove that x dou u by dou x plus y dou u by dou y equal to sin 2u. So again, just like in the previous problem, you can write tan u equal to x cube plus y cube by x plus y. You name it as a new function z of xy. Then z of kx comma ky is k square into z of xy, because replacing k x by kx and y by ky, you will get k cube in the numerator, you will get k in the denominator is common. So k cube by k is k square. So therefore, z is homogeneous of degree n equal to 2. So by using Euler's theorem, for z we have x dou z by dou x plus y dou z by dou y is equal to nz, which is 2z. But what is z? It is tan u. So this implies replacing z by tan u, you will get x dou by dou x of tan u plus y dou by dou y of tan u equal to 2 tan u. Now this is x into tan u derivative is secant square u dou u by dou x, y into secant square u dou u by dou y equal to 2 tan u. Now dividing both sides by secant square u, what you will get? X dou u by dou x plus y dou u by dou y equal to 2 tan u by secant square u, which is 2 sin u by cos u into cos square u. 1 by secant square u is cos square u, which is 2 sin u cos u, which is sin 2u, the required answer. So this is mostly asked problem in the examinations. Thank you. Meet you in the next class on partial differentiation. Thank you.